as t goes to 2 of 40t minus 16t squared minus something over t minus 2. What goes right here? Yeah, what's y evaluated to? It's going to be 80 minus 16 times 4, so it's going to be 16. Yeah, there it is. Please don't swear. T goes to 2, you end up with, if you're going to do this, you need to clean it up a little bit, negative 16t squared plus 40t minus 16 over t minus 2. Can you plug in 2 for t right now? No, you can't. You want to be able to cancel it out, so what are you going to need to do to the numerator? Factor it, factor it, factor it, factor it. What's the first thing you could pull out? You could pull out 8. How about we pull out negative 8? Is that okay? How about negative 8 times the limit as t goes to 2 of 2t? You sure can. Plus, oh, it's going to turn to minus, right? Minus 5t plus 2 over what? T minus 2. And at this point, what? Totally can do that. Just multiply by 8 at the end. You can factor it out. You don't. It's along for the ride either in front of or in back of the limit. Either way, you're going to multiply by negative 8, right? So can you factor the top? You hope. Well, when I say factor, can you factor anything? Yeah. The real question is, does this factor nicely? Does this factor with? Yeah, it does. You want. It's 2t, right? Well, you know, listen. Kids, this is important. You want that to be a factor of the numerator, right? You want that to be a factor of the numerator. So you put it up there and hope you can figure it out, right? So it's, is it plus 1?
No, it's minus 1.
I think it's going to be minus because I factored the negative out, yeah. Like this? Come on, Casey, you're right. So what cancels? That cancels, so you have negative 8 times the limit as t goes to 2 of 2t minus 1. It's going to be negative 8 times what? 3, right? Equals negative 24. And now this is a velocity. What's the unit of measure on this? It's meters per second because they give the distance in meters and time in seconds. So what does a negative velocity mean if you're throwing a ball into the air? It's coming down. Negative, it's just coming down. It's coming down. So if we focus on the numerator to subtract fractions, what do you need? Common denominator. So let's move this over for a sec. Let's move that over. And what are we going to multiply that by? We're going to multiply this by root a over root a. And what are we going to multiply this by? Root x. So what do you end up with? The limit as x goes to a of root a minus root x all over root a times root x all over what? X minus a. And I can simplify it just a little more and you end up with the limit as x goes to a of root a minus root x all over x minus a times root a root x. All I did was bounce it up to the numerator. We're left with this. Can we plug in a yet?
No.
No. But is that a little cleaner? Yes. That's a little helpful. The problem is you still can't plug in a for x, right? So you want to somehow cancel out x minus a with it itself in the numerator. Are you allowed to square this? Please say no. No. It doesn't equal anything. Michelle? Nope. Root x plus root x over root a plus root x. If you do this, look what the numerator becomes. You get a plus root a root x minus root x root a minus x. Do you multiply out the denominator? Please say no. Because you want to cancel. You want factors to cancel out. If you multiply it out, it will be very hard to cancel anything. You still put it on the bottom. So look what we did. You multiplied out the top because now what cancels? This cancels with that. So what are you left with? You now have the limit as x goes to a of what? A minus x over x minus a root ax root a plus root x. We're so close. Do we almost have what we want? Yeah, we need to change either the top or the bottom though. So what can we factor out of the top?
Negative 1.
You can change it to this, and if you factor out a negative, it turns into x minus a. So now it cancels. The opposite of a minus b, you can put that in, it turns into b minus a. So we factored out a negative sign. So what cancels now? The x minus a and the x minus a. So now we have the limit as x goes to a of negative 1 over square root of ax times the square root of a plus the square root of x. Do you agree with that? Can you plug in a now?
Yes.
Yeah, you end up with negative 1 over what?
A.
The square root of a squared times the square root of a plus what? Plus the square root of a. So you end up with negative 1 over a times 2 square root of a. What's the power of just a? 1. What's square root? What power is square root? 1/2. So you have negative 1 over a to the first. You put the 2 out here. You can do that. And it's a to the what power? 1/2 because it's in the denominator. What do you do with the exponents when you have the same base? You add them. So you end up with negative 1 over 2 times a to the what power? 3/2. Because 1 plus 1/2 is 3/2. Right? Right? So if you want to write this right here, it's going to end up being negative 1/2 a to what power? Negative 3 over 2. Because it's in the denominator. There it is. If you did it this way, you got it right. If you used any sort of derivative function, you totally got it wrong. And not only will you get the points taken off on your exam, I'll take off negative points on your exam, okay? Right now, you must use this method to find derivatives, which is exactly what we just did. So this is the slope. So Julie, can you tell me the equation of the line? If this is the slope and this is the point, what's the equation of the line?
Y minus 1
Yep.
equals negative 1/2 x minus 1.
Done. Stop there. Done. Stop. Don't go any further. Now, you're going to do the same thing for 4. So you have the point 4 comma 1/2. The slope is going to be negative 1/2, 4 to the negative 3/2. You have to know what that is. Negative 3/2 means you square root it, you cube it, and you put it all under 1. What's the square root of 4? What's 2 cubed? 8. So this is equal to negative 1/2 times 1 over 8. So that's equal to negative 1 over 16. So what is the equation, Andrew? If this is the slope and this is the point, what's the equation?
Y minus 1 over 12
Yep.
equals minus negative 1 over 16.
Yep.
X minus 4.
Yeah, that's it. Stop right there. Excellent. I think part C asks you to graph it. Is that what it asks you to do?
Yeah.
Yeah. Like a
You can graph each of them, and each of these, should you be able to visually tell if it's tangent or not? Yeah. If it crosses, is it tangent? No. I'm not going to take the time to graph it right now. So once again, you have two methods at this point. You can either, this would be the exact method right here, but if you had your calculator, could you come up with a pretty good guess by graphing this function and zooming in at 1? Yeah, absolutely. Did the spike go away? Yes. Theoretically, if we zoom in further and further in on t equals 1, in this case x equals 1, what are you eventually going to see? Eventually your calculator is going to, what's going to be there? At 1? A hole. Eventually you'll see a hole. That's what we want to see, right? But let's just use the trace function to get an idea. So we could use the trace function, and we're looking at when x goes to 1, right? When x goes to 1, look at the y value. See the y value right there? Oh, we went past it too far. Again, resolution is not very good, right? So what do we have here? Here's our graph. Freaks out a little. It's fine. So we have this. So if we look at this, what does this look like the estimate's going to be right here? Our estimate's about this, right? Kind of looks like it's 56.33. The problem with this is it's not exact, right? We'd like an algebraic way to do this. Could we make a table and make this even more accurate if we wanted to? Yeah, we can make a table. Just say, yeah, answer. What do we want this? Oh, look, I even have the starting value starting nicely. I might have done this one earlier today. Okay. We do second table, and what do we get? Oh, it's climbing. Should there be an error at 1 right there?
Yep.
Yeah, there should. So does this give us an even better estimate? Yeah, it gives us a better one, but our initial estimate wasn't that bad, right?
Yep.
But again, are these 100% accurate? No, these are still estimates, right? You can only zoom in so far. So let's actually do this long division right here. Let's do the long division. And what should the remainder be when we do this division?
56.
No, the remainder. What should the remainder be? The remainder should be 0, not 50. So if we do this, remember, what's the phrase you need to remember? Leading over leading. Remember that? Leading over leading. What's the leading term? Negative 0.83t squared over t. This right here is always the leading term here. That's always the leading term. So what does that equal? What do we put on top? Negative 0.83t. And now we have to multiply, right? So you get negative 0.83t squared plus what? T. What cancels?
17.
What cancels? Thank you. It's 1/7. That was the mistake we made before, right? So we do that. Let me correct that up here. This should actually be 7 right there. So if we do that, we subtract. These cancel, right?
Yep.
And you're left with 58t minus 0.83t. What can you factor out of that? You can factor t out, right? There's t. Do you agree that there's t in both of those, right? I'm just doing it in 2 steps here. So what does that actually? That actually turns into what? 57.17t. Do you agree with that?
Yes.
Okay. So now you have 57.17t over t. What does that equal?
57.17.
Now you have to multiply, right? You bring down the 57.17, and you get 57.17t minus 57.17. What subtract? Oh, is that great? Yeah, you really like that, right? So what does that tell us this is equal to? It tells us that, this is what's really important here, the limit as t goes to 1 of 0.83t squared plus 58t minus 57.17 all over t minus 1. What does that equal? Negative 0.83t plus 57.17. We've actually completed the next question as well. If we just did the general one right here. So this is velocity at 1 second. If we want the velocity at 1 second, what do we plug in for t? We plug in 1. Let's try this and see what happens. Hold on a sec. Yeah, let's try it and see what happens. We get negative 0.83 times 1 plus 57.17. What's that equal? So it becomes 56.334. So was our initial estimate pretty good?
Yes.
Our initial estimate was very good. We've actually done the next one kind of inadvertently. The next question asks, look what the next one asks. Do it when t equals a. Can someone tell me what the velocity is at time equals a? We already did the work, all of it. The velocity at time equals a is going to be what? Negative 0.83a plus 57.17. Yeah, there it is. Right there. Pretty cool, huh? Is that magical? So it's when 58t is equal to what? Well, minus 0.83t squared is equal to? So that's when 58t is equal to 0.83t squared. So what's one trivial solution? What's the easy solution to that when t equals 0? But we already knew that. It's fired from the ground, right? We want to know when it hits the ground the second time. So that's when 58 is equal to 0.83t. So t is equal to 58 over 0.83, which is at can someone do that for me? 60 something and change. 0.83, what is it?
69.695.
Point what?
7.9.
795?
Yeah, 879.
8795? Is that correct?
Yep.
Okay, so that's when it hits the ground. What does D ask? D asks what's the velocity when it hits the ground, right? Do we have to do another limit to find that velocity? No, we know that the velocity at time t is, remember what it was? Remember what it was? Negative 0.83t plus 17, right? Correct? So how do we find that velocity? Well, we do v of 69.8795. So that's going to be negative 0.83 times what? Times what? 69. We're plugging in. We're just evaluating a function, kids. 57.17. Can someone do that on their calculator and tell me what they come with? T in there. So this would work right here just for 1. So if we wanted to make this general, this is totally my mistake here, and we're going to end up doing some very similar stuff here. This doesn't work because we use time equals 1 for our general case. But by definition, if it's a general case, can we use time equals 1? No, you absolutely can't. What's the time for our general case? A. So I'm sorry, I got a little excited, I guess. I thought we were moving nice, and we were. We're going to do, this should be pretty easy now. Everybody put your pencils down, stop writing, everybody look up, do not write, don't hold anything in your hand. Just ignore it for now, okay? You can get it later. What's the general limit going to be? The limit as as t goes to what? T goes to a of, yeah, let's just write this out once. F of t minus f of a over t minus a. Not what? T minus 1. Thank you for pointing that out. I couldn't quite see what you were saying. I now do. You'd think I would get it right doing it already today. Oh well. Do we know what f of t is?
Yes.
Yes, it's 58t minus 0.83 t squared. And now what are we subtracting? 58a. Is this a little different?
Yes.
A squared. Do not write anything down. Do not pick anything up. Please just watch. T minus a, and it's the limit, right? So now we need to simplify. We're doing the same thing we just did, but with different numbers, right? So what we have to be very careful about this. We need to reorder it. It's t minus a, so it's going to be negative 0.83 t squared, right? Plus 58 t, correct? And is it okay if I just keep those grouped together like that? Because these are just numbers, right? What I mean by that is a variable? Not really. It's treated like a constant here, right? And what's this all over? T minus a. Okay, so before we had that 57.17, right? The only difference now is it's not 50. That 57.17 changes as a changes. The reason we had 57.17 is because we plugged in what for a? 1. Should we have done that in the general case? No. But we have a very good idea of what to do next, don't we? What do we have to do now? What do we have to do? We did it before. We can't, no. Hold on. I don't expect you to know how to factor that out of thin air out of your head. So what method are you going to use? We just did it. No, not grouping. No. Okay, so what do you want to group?
The 58t and the 58a. You get t minus a, and then you can process.
Okay, so I see where you have to be very careful. Do you remember how we did this yesterday and we did it wrong? Just be very, very careful about this. Okay, this is what Hunter wants to do, and I will do it this way, but what I wanted you to say was polynomial long division, because that's what we just did. I like your idea better. Let's see if we can make it work. I can't guarantee it'll work nicely, but let's see if we can do it. Now you need to spit your gum out. Here we go. So we have the limit as t goes to a. What Hunter said was he wants to do this. He wants to group like these together right here. You see that? What can you factor out of both of those? So you get 58, and what's left?
T minus a.
T minus a. So he wants to do this. You can do this. You have to be very, very careful. And you see this? You have a negative and a negative, so that is actually positive right there, correct? What can you factor out of both of those?
Negative.
Yeah, you have to figure.
Negative 0.83. You're going to be t squared minus a squared all over t minus a. You have to be very careful at this point, but you are basically home for, you can't cross stuff out yet. What do you have to factor? The t squared minus a squared. This is great, and it does work. You just have to be very careful. Remember what we did yesterday? A is not t. Remember that? I was really happy.
Wait, and then this is if I had a T and A separately?
No. So you have 58. Sorry, you can, but it doesn't give you what you want. You want to have, so look what happens here, Casey. You can do that, but it doesn't get you anywhere. The reason you do this is because what is this? T minus A times T plus A over what?
T minus.
Now that you have T minus A in both of the terms, what can you cancel? You can cancel the T minus A's everywhere, right? So this cancels because of that. You can cancel it in both places. So what does it become now? The limit as to A, yep. 58, please put the paper down. Exactly, you're doing, kids in the back, girls in the back.
T plus
Over.
over and up.
Oh, it cancels, that's right. That was the whole point, right?
Yeah.
You're right, okay. Okay, good, so we do this. And now we get something that's actually going to make sense. So now can we plug in A for T? Can we plug in A for T?
Yep.
Yeah, so you end up with 58 minus 1.66, 56A. I just plugged in, look, it becomes T. No, it's T. Look, it's A, right? So it's 2. What's 2 times this? So this actually will make sense and give us something that will work, okay? Got it? Now, but here's the thing. What was our estimate for the velocity at time 1? You ever written down, I'd imagine? Velocity at time 1, you ever written down, right? Nope. 56.33. Do you remember that? We just did it. Okay, kids.
795.
8795. Is that correct?
Yep.
Okay, so that is when it hits ground, right? So we want the velocity at 69.8795. Hold on one sec.